Hello guys, welcome to my workbench again. As you can see, there's a new project on my workbench, and it's actually a capacitance meter actually, and also a set for making a band spread on your receiver. So it consists of a meter for meeting capacitance, and also sort of griddipper inside. And on top of the box you can see a little digital counter that will be installed on top later on in a little box like that. Now you can't see that properly actually, so I'll move it up a bit. Okay, there you go. There you go. That's the intention, perhaps on the back there. I don't know where I'm going to put it. Put it in a little nice box, and then we can make a readout of frequencies. So it is actually a band switch. I will explain it to you. This is a band switch, 5 bands, covering from the broadcast band up to I suppose the 10 meter band again. And then we have here, a switch for 4 capacitors, starting from 100 picofarad up to 100 nanofarad. So that's the range. That is a tuning capacitor, that is a tuning capacitor, and that is a tuning capacitor. So that's the outlet for the capacitor outside in the receiver. So what you're actually doing is then, I'll explain that later into the second part. Then we are going to use this meter, and then we make a band spread, and you can do all sorts of things with it. You can measure our wiring capacitance or something like that in that receiver, because it plays a role in that setting. If you want to make a band spread, then you have to take into account your wire capacitance and your valve capacitance, and so on and so on. Everything has to be done that way. Okay, so far so good with my sermon. So I'll put that aside for a minute. I'll take the cover off. There's a nice little cover, and then I'll show you inside how it is laid out. So I'll just turn it around for you. See if you can see this. Cover it up a little bit. Now you can see our switches and not the capacitors. So you can imagine that we have to make all the other things, like a transformer, power transformer, consisting of 200 volts will result in 300 volts plus. The filament 6.3 and 12 volts to employ our counter. So that's so far as we got. So that is only about a day's work what I have done to figure everything out. I think I put more time into doing this all up. So how that should be and how it should function. So that's always the way with a project. If you start a project, be sure that you know where goes everything, and what you want to do with it, and how it should function. So I thought about that a lot. So that took me a couple of days, and then you start to mark everything out on the front, where the parts have to go, and you think over and over and over and over again. So that is the way you do this thing. Anyway guys, we have a transformer here again. There it is. Let's shove him aside for a minute. So that has the little transformer. Will be probably, I thought about it a bit, put them up there somewhere at the top. Can you see it? No, you can't. I'll put it forward. You probably can see it. You see a little bit of it. Anyway, it will be on the right hand side on the top. I will put that little transformer in there. It will be an ECC 82, I suppose, with an EC92 valve and a rectifier valve. So that will be the thing. The first thing I'm going to do next is to make the layout inside for the capacitance meter on that side here. I'm going to make the layout of that with the valve and everything, and I can use my bench power supply to power it all, so we can actually see what is happening. So that's a very nice thing to have a power supply on the bench that you can supply yourself with all the voltages you need. It's not necessarily then that you have to construct a transformer and so on and so on, with all the risk from that. So if you have that on, put that on the net, then the chances of a shock are great. It happened in the other meter as well. I wasn't careful enough, and then you get a shock, and then like somebody hits you and you see nobody. So anyway guys, you can see my progress, and I will come back to you when I have more, okay? Welcome back everybody. Well guys, I will inform you what I have done. First of all, I went on with making our capacitor meter, what we need on parts. There are two Schottky diodes in here. The one is underneath there, and the other is down there. Okay. Now on the other side, we have to make our sort of griddipper on this side. Okay. That's what I've done. So so far so good. What I also have done is get those capacitors in there, 100 picofarads, 1000 picofarads, 10,000 picofarads and 100 nanos, 1.0 microfarad in there, and I put my my VRs in there, my trimming VRs, so I can adjust or calibrate the meter. So when I measure capacitance, that will correspond with the scale that is on there. Okay. There are some parts on the bench already, what I need for our griddipper, what goes in there. So you can see it is on one side we have the valve of how you call it, our capacitor meters, the ECC, and the other side we have our griddipper, you see, and that's the way it goes in, that way. Alright, and then we have to make a little board to put our rectifier on, so I put that into place. So I will do that. I will wind my my transformer. I made some distinction already, as you can see. I separated that from ground, both sides. That has a reason, because this is not, how you call it in English, as I say it in our way, is a galvanic coupling on ground, so they're separated from ground. Otherwise you can't measure any capacitance. That's the way the schematic looks like. On the other hand, you have to separate our griddipper also in that for that matter. So have no influence. Apart from that, we have two 6.3 voltage for the filaments separately, because of our separation from ground. So that's why I've done it that way. So far so good, so I will carry on with that. And another thing I want to report is I did some preliminary testing with a tuning capacitor, and I used my capacitor meter, this one, what I have. I used that one on that, so I had some goings on that. That works. It works well. It has its own wire capacitance of about 23 picofarads. you will find in most receivers you find that wiring capacitance applicable. So probably you have also your capacitance of your coil. Your tuning coil also has capacitance, so that will be added to it, but you can't measure that. Alright? So what you have to do, you have to use 2 trimmer capacitors to get in series and in parallel to tune that band spread. So I will demonstrate later on to you with this capacitor here. This is a 134/35 capacitor, and I will show you what it will do with a coil. See, there's a resistor coil. It works well, you know. On there, see, you can see that put a knob on there, and then you can see where that knob is going, what the stance is from the plates, and where it will tune on, say for ammeters on 3.5 and 3.8, and then you can see how a little difference that is if you tune that. So you have say 300 kilohertz to tune, so it's very small, and you have no room to turn that. So, and then I will show you with this apparatus how you can prevent that and how you can spread that space over the whole tuning capacitor. Mind you, it is not an easy business. You have to understand how that works. That's the first thing you have to do, and then on the secondly, you have to figure out this nomogram, how that works. You can determine your frequency. You can determine the percentage in correspondence with 300 kilohertz. Is that? Yeah, 300 kilohertz. You have to determine the percentages of that. So you have to divide the 400 kilohertz onto the frequency 3.5, and then you take the square root out of that, and then you get the percentage out on the left hand side. So, and if you put a ruler around, across that, and you have your minimum capacitance. I say you're going to use a microfarads are on this side. Then you see, say you want to use it 30 or 20. Then you put your ruler on say this 10 over to 20, and then you find out on this side your maximum capacitance. So then you know already what you need for 3.5, how much capacitance you need to get in resonance. I hope that is a bit of clear for you. And that is the basis of this meter. That is the basis of this meter. And this, according to this nomogram, you can determine your capacitance and your inductance you need in your coil. Okay, so that's so far. It's very important. This is very important, though. Otherwise, you are working in the air. You could do it in a different manner. You could probably do it put the coil across this capacitor, and then measure with a griddipper what the resonance is, and then you could determine your capacitance. You have to measure. You have to get it on, get it off, get it on, get it off. Yeah, but because of that nomogram, it will be a lot easier. That is to say, if you understand how that works. Okay. So I'm going to leave it in this video to that point. What I'm going to do next is to wire up my griddipper. There are a few problems to solve. I have to think about that, and that will take a bit of time. So I have a little coil here, and I thought by myself, well, I had some thoughts already, and I'm not going to disclose it yet, but to how I'm going to use this meter. So there are several ways of to measure resonance and so on and so on. So I have to determine for myself what is the best way to determine the resonance frequency on this capacitor. So you can do that in several ways. and I will choose the best way. You can use it as a dipper. That's why we have this little coil as it's experimental. I put another terminal on there on that side, I suppose, and there has to be another switch in there because of the switch between our capacitor meter and our griddipper. What goes in there, so if the capacitor meter is active, then the griddipper won't work. This meter works for capacitance and for the griddipper, so it has to be switched. So that's one of the reasons why I put a switch in. So a switch that goes via a relay. Okay, so that's how it is going to work. So that is the intention. Let's put it this way. That's how far I got. So guys, I will stop the video here again, and I will carry on, and then I'll come back to you. Okay. Okay guys, I did a bit more, so I connected everything up, the capacitors up here. I finished off all the wiring, the relay for the meter. This is the griddipper valve, as you know. I did wire everything up on that side here and turn them around. There you go. Now you can see our capacitor valve, or the ECC 81 is that what I use for that, and all the wiring what belongs to the griddipper, including the measurement for the meter. So so everything will be alright. So the only thing I have to try next is if our griddipper will oscillate. I have to check that because I didn't stick to the schematic, so I had to have some experience concerning a griddipper, so I have something in mind to connect this all up together so that it works together. So I had to put some thought into that. The next thing to do is to wind our transformer that's going in here, and get our if you can see this little board here, put that in here and put in a socket on there, valve socket on there, make it strip, can mount them, and then we can put that together. Then we can hook up our power supply from the bench, and then actually we can try what he's going to do. This meter on front here will switch between the capacitance meeting and functioning for the griddipper. So, and that's that relay that's on this side here. Yeah. When the relay is off, in the off stance, then the capacitor meter will work. As soon as I switch on the 12 volts, then the griddipper starts to work, and it switches over to the griddipper, and then the capacitor meter will have no voltage. There's another relay here, smaller one. I will switch to high voltage with that, so we can swap between those two. Yeah, that's so much as I can go. But then I have to connect up our power lead, our power switch, perhaps this little switch to switch the meter, what goes on the back. There will be probably another terminal here on the front, I mentioned that already. So I'll have to do that. I have to think about that still, because perhaps I do, perhaps I don't know. So just go by as it is. Okay, that's as far as it goes, guys. Later on I will explain everything, so when we are that far, then we will check together our capacitor meter. how he's working, and we will calibrate them. And the next step is then check our griddipper if he oscillates, very important. If he doesn't oscillate, no business, you have nothing. So you have to make sure that he oscillates, and then we have to put it in combination with our settings on this right hand side, so that this is going to function as a dipper. So you can see the dip on the meter. Okay guys, so far so good. So I will stop here the video again, and I will carry on what I said, making that little board and binding the transformer. Put it all together, and then we'll check it with our bench power supply if everything works as it should, and then we connect up our power supply, our transformer, and put our net lead on, and so on and so on, and that will be it. And then we make a new video concerning our capacitor meter. Let's have a look. So that I can use our capacitor here. We're going to use that one, as I said before, and I'll take it from there. Okay guys, I'll see you later. Hello everybody. Well, he's in front of you, part of the power supply. I built, so the next thing to do is get my transformer into place. So yeah, before we do that, I will do some testing anyway. So not everything is in its place. The switch has to go in still, and the fuse, I have a fuse here for the high voltage, and we have for alternating current, we have a fuse as well. So before the transformer and before the valve, so I can protect the valve, that's all. So when I get my power supply on here, put it on that one. So yeah, I have to put that other switch in still, so but it won't be today anyway, so I had enough for today. So guys, I will see you on the next part, okay? Hello guys, welcome back again. Well, as you can see, our transformer is in, so I've fabricated that as well. I put I put a fuse holder in there, a switch, another relay to switch everything on that part. So I had some tests with my little coils. Well, it didn't work out as it should work out, at least not what I expected. But it doesn't matter, it covers the band, so from back to front and from front to back, so that should be okay. There were some minor issues with our capacitors here on this front, so I solved that as well. Yeah, but there's some more to say. I'll turn around. I got the other relay in there for the meter, so that it will switch back to forth. So with the off stance, the capacitor meter will work. I didn't calibrate the meter yet, so I didn't get around to that. So I want first have the transformer working and all the trimmings that belongs to it, so 12 volts and so on and so on. I just made it that way that this valve easy 41 will glow, the filaments will glow always. And on the other hand, if you look down there, we have our ECC 82. I've kept my transformer out of one. So I didn't land him yet because there are some solder work to do on my transformer still. So I did start on it. This is my net lead is here, and this is my filament, and this is the 200 volts what goes up to the rectifier valves. So anyway, you can see, and I'll show you. I have my primary 235 here, and my 200 volts I have here. Then I have a 6.3 volts over here, and I have a 6 volt, that one and that one here. So this one is a 6 volt, and this one is a 6 volt, and this here is 12 volts. So I have to connect that all up. Then I drilled some holes in there. I'll show you. I drilled some holes in there to mount the transformer. So yeah, I've got my little things on there so that it looks nice. So anyway, guys, as you can see, we are well on our way. I will finish this off, and then we go up to the part where I have to calibrate our meter, our capacitor meter. So well, I will do that in a new video, and I'll tell you why. Then we can go straight on to capacitance meeting of our capacitor, tuning capacitor, the bandspread capacitors, and so on and so on. Then we make that all one video of, and I think it will be more entertaining, so you can see straight away what the result will be. Then you can see our meter working in capacitance and also as a dip meter. So I discovered my frequency counter has a malfunction yesterday. All of a sudden started. I couldn't get them into the right connection, so that presumably there is a soldering contact that is gone loose over the years, I suppose. Just got loose. So if something is wrong with electronically wrong with it, it won't work anymore. So it's as simple as that. So so I have to open them up and have an inspection on that particular switch, see if there is something there that is not right. So I will resolder that a little bit, and hopefully it will come back then for me. So I expect no problem. So anyway, guys, this is concludes this part 1 video. I will put it on the net. You have to wait for the second video. Sorry about that. Yesterday it was Shabbat, so on Shabbat I won't do anything, so we have to respect that. And there we go. We see from there. So guys, I wish you a beautiful Sunday, and I'll see you the next time round. And thank you for watching.